Alright, this is the topic 15 video. And as it turns out, topic 15 is directly related to topic 11 from the previous unit. So the good thing is, in preparing for 15, we also review 11. So for many of you that didn't get 11 the first time, this is a chance for you to get extra practice. Maybe carve some time out of class and come see me and we can work on that topic. Or if you do figure it out with some extra practice, you can go back and retake this one question and improve your grade. The challenge is that you need 11 to do 15. If you can't do this, you can't do this yet. And all that means is, if you can answer this question, that means you understand how to use these formulas, which was what topic 11 was about. So, if you can't do them yet, and yet's the key word, then let's practice. Come see me, or find some friends that are in the same spot. But what I would like you to do is answer this question. If you can't do this, don't watch this video. Go back and watch topic 11 and maybe do some of the practice related to it. Or come see me, or find a friend. But until we get how to use these formulas, we're not going to be able to do this new idea. So solve for this right now. Even if you're confident you can, solve for it. Okay, here's the answer. It's moving at 15 meters south. So let's see, V initial. That's how fast it's going when it started. Child runs into the street, slams on the brakes, comes to a stop. V final equals 0. In 20 meters. Distance final equals 0. That's the same as change in distance. Sorry, 20. D initial is always 0. We don't know acceleration. So we want a formula that has all these that lets me solve for A. This one has time, can't use it. This one's average velocity, this one has time. I put this one up there twice, sorry. So let's plug in our numbers. 0 squared equals 15 squared plus 2 times A times 20. Okay, equals, calculator, 15 squared, 225, plus, combine these two, A times 40 equals 0. And now I can't combine these two. First thing I have to do is move 225. It's plus, so I'm going to do minus because we do the opposite function on both sides to move it over. Negative 225 equals A times 40. The last step is to get A by itself. This is A times 40, so divide by 40. 225 divided by 40, 5.62 meters per second squared. Okay, moving on to the new topic. Alright, by the end of the day you'll be able to apply acceleration formulas to solve for force on a moving object, and then be able to solve for acceleration from a graph in order to prepare for our next project. And actually I'm going to do this on a separate video. I'm going to do this on the 15 project video. Or I'll probably do it in class. This will be in class as I introduce the project. So we're just mostly doing this first one. Vocab's nothing new, it's just all our velocity vocab. And this is 15 part A. There's actually a part B to this, and it's an extra credit opportunity. It should be on page 21. This is a combination of this formula and topic 11. So once again, this is worth reviewing because you can reassess and improve your grade from the old topic. It will also help you during this unit. So you kind of get help on two different topics in completing this one. Okay, I'm going to go right into example 1 because there's really nothing new. It's combining a formula we already know with a topic we've already gone over. So I'll solve for this first one. So let's read through. The first thing we want to do is identify what's the question. Solve. So all I did was I took the question that we solved for from the beginning warm-up, and now I want you to solve for the force applied if the mass of the car is 1,000. So this is new. This is the only force formula I know. I know the mass is 1,000. Oops. M equals 1,000. The acceleration we solved for, you can rewind to the beginning if you want to see how it was done, was 20. Shoot, I don't remember. Okay, I got it. It was 5.62 meters per second squared. But I had to do a bunch of stuff using the other formulas to get this, and that's kind of the gist. Do some stuff and use the old formulas in order to find for acceleration, and then use the new formula for this unit. So 1,000 times 5.62 equals 3 times 1,000, 5,620 newtons. So let's try another one. Okay, what are we trying to find? First thing, what's our question? Question is F equals question mark. What's the magnitude of the force applied? Formula for that is F equals ma. You know what I forgot? Will you guys do me a favor? Have these written down and put them on this page. But pause the video and write down these formulas so you have them in this unit notebook, because obviously we're going to need them now. Okay, so you got those formulas written down. You can put them on the top of page 21. Now I need this. Let's see what I know now. I know we have a 5 kilogram load, 0.5. Dropped from rest, V initial equals 0. After 3 seconds, time equals 3. V final equals 29.4 meters per second. So, I know mass is 0.5, but I don't know acceleration. I need to use this stuff to find it. Look at your formulas. Which one is it? V final equals V initial plus AT, or acceleration equals V final minus V initial over time. 29.4 minus 0 over 3 equals 29.4 divided by 3 equals 9.8 meters per second squared. But we knew that already, so this is kind of a shortcut. You could do this one without it. 9.8 times 0.5. 4.9. So those two together equal force, 4.9 newtons. So that was kind of an easy one, because you technically already knew the acceleration to gravity, but you could also have solved it using the info. Last example. Okay, I know that mass equals 15. And there's also a 45 kilogram kid on the bike. So the total mass is 60. Starts pedaling from rest. V initial equals 0. Max velocity of 3. V final equals 3. In time of 6 seconds. Calculate the force. The friction slowing down the bike. So it's actually force of friction. As a child applies a net force, child applies a force of 30. So force applied equals 30. Picture, kid on a bike applies a force of 30. we want to find force of friction. We know the whole thing is 60 kilograms. If we can find the net force, then we can figure out how much is resisting it. So, force net equals mass times acceleration. I don't know acceleration, I need to find it. I can use this stuff. Acceleration equals v final minus v initial over time. 3 minus 0 divided by 6. 3 divided by 6 equals 0.5 meters per second. So F net equals 60 times 0.5. Which is 30. So if the net force is 30 and the applied force is 30, that means that this is actually a 0 force of friction. Alright, so there's a practice problem at the end, and then there'll be some textbook problems listed on the blog for you to do on page 20. Cheers.